dear fellow traveler under the moon. I saw you standing in the shadows and your eyes were blue. You put your hand out, opened the door. You said, come with me, boy, I want to show you something more.
Geology! 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 Welcome to Mini Geology radio show. This is your inquisitive geologist Daniel Minisini. This is KPFT HD2 channel. We are in Houston, Texas. Welcome everybody to this show that connects our beloved geology with society at large. Welcome very much to everybody. Today we're going to talk about the moon, and we're going to talk with Jack Schmitt, the only geologist that put his feet on the moon. Yes, we are going to talk about the moon and why do we go to the moon. If I could be a little bit philosophical, I would say that it's easy to grasp objects and phenomena that surround us. For instance, we can say a stone under the sun gets hot. That is related to our intuitions. But we have also other things than intuitions inside ourselves. We have the concept of space and the concept of time. Hence, we can do more. We should do more than those simple observations. In fact, we, as human beings, we do research. Research in the lofty meaning of the word. We research and we try to connect our intuitions. A stone under the sun gets hot. We connect the intuitions to our intelligence or our concepts. Remember, like the philosopher said, cogito ergo sum. So in this case, we don't only say a stone under the sun gets hot, but we reach another level when we say the sun warms up objects. This is making science, giving universal value to our observations and our intuitions. So this become knowledge. And we have the duty, it is our nature as human beings, to move towards knowledge. And this is why we go to the moon. This is why we hike Mount Everest. This is why we try to go to Mars nowadays or beyond. This is why we look inside into the earth, or why we dive into the deepest abysms in the ocean. This is the reason why we split the atom or we cultivate stem cells. So this is our food for thought. Or these actions that I just described, they also give input to philosophers and therefore to our leaders. We may say also to politicians. Very important concepts, because if we find new life in other planets, if we find that our species will disappear, if we find that our solar system will shut down in 5 billion years' time, if we understand that the material is or is not indivisible, if we understand how to clone our body or our cells, if we get that animals may think and have feelings, well, then we'll change our perception of the world, and we will change ourselves as a species. We will behave differently. We will have new goals in our lives. We will have different relationships with others. We will think in new, different, and more informed fashion. And all of this is because we do research. So we need to study what are called the laws of nature to increase the knowledge. Because if we do that, we help to locate ourselves in the world. And therefore, we push forward religions, and we create new thoughts and new concepts. Just as an example, think about when we change our perception of the position of the Earth in relationship with Sun. Before, we had a concept that was Earth-centric, and now is heliocentric. And just think about the repercussions and the cascading effects about that paradigmatic change. Well, I think I need this introduction today to talk with the only geologist that landed in our satellite, our dear moon. And we're going to talk with Jack Schmitt. I'm going to air a pre-recorded interview that I made with him. And I would like you to think what an amazing adventure and experience he had. And just think that what he did, it did it for all of us. And I hope you can feel his experience as yours. All right. So Jack Schmitt, welcome to Mini Geology. What a pleasure to have you here.
Good, appreciate it.
How was perceived geology in the Harvard University when you studied there in the 50s and in the 60s? How was
Harvard in that period of time, in the late 1950s, early 1960s, had one of the strongest groups in earth science in the world. There were Jim Thompson was there in metamorphic petrology and thermodynamics. Bob Garrels was there in geochemistry, humochemistry, and economic geology. The geophysics group was very, very strong. Paleontology was very strong at the time as well. It was just a very, very good place to do graduate work. Now, Harvard, unlike Caltech, tends to go through ups and downs. They tend to have a senior group of professors, and when they retire, then they have to rebuild again. Caltech tends to try to populate their professorial group, their teaching group, on a continuous basis, so that it doesn't have quite the ups and downs that the Harvard group has. And so I was very fortunate, and a number of geologists were very fortunate to have been able to go through Harvard. There was sort of a route, Caltech undergraduate, Harvard graduate school. Sometimes people would get masters and go back to Caltech for a PhD, but it was a very strong relationship, informal, but still a very strong relationship.
I know that you got a Fulbright fellowship, and you went to Oslo, and you spent 1 year abroad there. Why did you choose Norway?
Well, there were a number of reasons. Ian Campbell, my advisor at Caltech, and later the state geologist of California, a very famous geologist in many ways. He was president of the Geological Society of America at one time, and just a tremendous individual and a very fine man as well. He recommended that I, first of all, consider getting a Fulbright and apply for that. He started working on me when I was a sophomore, as a matter of fact. And I finally gave in and sent in my application. And we decided that for a number of reasons, Norway was an excellent choice. It has a very, very strong tradition in the earth sciences. At the time, Thomas Barth, professor of geology there, was really one of the top earth science field geologists and petrologists in the world. And it just seemed like a logical place to go. And it helped that they didn't require knowing the language before you went. It didn't mean that they didn't try to teach it to you when you got there, but nevertheless, it was not a requirement for going. So Norway was a very logical choice. It's a magnificent geological environment. It's been glaciated, so there are lots of outcrops. It's the kind of place for young geologists, at least, that can get a great deal of learning.
At that time, geology in Norway was so strong because of the oil discoveries?
Oh, no. Oil had not appeared on the horizon. There were no blue-eyed Arabs yet in Norway. And no, it was strong just because of basic fundamental geology. And really, Professor Barth was probably the most important figure at the time. But it was... had a very, very strong geological tradition for decades before, and really it was the work at the University of Oslo, at the University in Trondheim, and also at Bergen was excellent, and so it had a good reputation throughout the profession.
At that time, you had a fellowship. You knew you were good in the geology. Where did you see your future at that point when you were studying abroad?
Well, it was an opportunity to study and to broaden my geological education, but my intent at the time was to go into what we call economic geology, and that is particularly into ore deposits of various kinds, and work there. And in Harvard, one of the principal figures at Harvard at the time was Hugh McKinstry, a very famous economic geologist in the mineral industry. And my father recommended him very strongly, my father also being an economic geologist. And so I was looking at Harvard for economic geology. That was on what I thought was on my horizon.
So your interest of geology comes from your family legacy?
Yes, a combination of my father and mother were both very interested in science. My mother, a teacher, an English teacher, but nevertheless interested in botany and birds and other natural life. And where my father was one of the more prominent economic geologists in the country, if not in the world at the time.
Huh. Then you end up on the moon.
Well, that happened, like we sometimes say, you make your own luck by getting a good education. And when the opportunity came to volunteer for the Apollo program as one of the first scientist astronauts, well, then it was a pretty easy decision to make when you look at having that opportunity.
Yeah, so we reached that point in which we're going to ask one of those many questions that Jeff has asked about that December 1972. So, yeah, my question here is, which is the most asked question about such an amazing experience that you had walking on the moon for 22 hours? Which questions do people ask you about that?
Oh, well, the most common question from a non-scientist is, of course, what was it like? And it's impossible to describe many of life's most wonderful experiences because you have to be there. Being there is the essential human ingredient, and just reading about it or hearing about it is not quite sufficient, because the second most asked question from non-scientists is usually, well, but what was it really like, even after you tried to answer the first question. So you have to look at those experiences in the context of what kinds of similar experiences people might have had. Standing on the rim of the Grand Canyon for the first time, maybe making the top of Mount Everest for the first time. There are many such experiences individuals have, and they're important and unique because they're more than you ever anticipated they would be. And that's what being on the moon was like, and actually being in space was like. It's more than you could ever anticipate it would be, and you have to be there. And so that's why it's so important for us to have a very broad-based space program sometime in the future, so more and more individuals can have that kind of experience.
So it's a problem also of communication, to communicate which was your experience.
No, I don't think it's a problem of communication. I think it's an impossible thing to communicate. I just don't think you can do it. You have to be there. Now, some people can give part of the experience better than others, but ultimately you have to be there.
That is the same thing that Dante Alighieri says in the Inferno, in the Paradise. He says there's no way to describe it. It's over the human beings, you can't do it.
Well,
but he did it.
Well, he did
But
it.
he was not there.
But he was not there, and fortunately for him. But it is still something that we just have to recognize. There are those kind of experiences that are very personal, and something that you have to be part of. The first time you fall in love, the first time that you have a child, all of those things are probably comparable in that sense.
Which is the most asked question by researchers, scientific persons.
Well, it's usually why was it important scientifically to go to the moon, and the primary importance, and we knew this before we went, but we didn't know why we knew it. We just knew that it had to be important. That the moon would tell us a lot about the early history of the Earth. We didn't know how much, but it still, we felt that it was important. It was a companion of the Earth. You could tell from its density and other properties that you could measure before we ever went there that it had affinities to the Earth in terms of composition and probably origin. But it was sort of a belief, I think, among most Earth scientists who were interested in the moon, that we would learn a great deal about our Earth by understanding the moon. And indeed, we learned more than we ever could have expected. Very few Earth scientists believed that the surface materials of the moon were very old. Well, when we got there, we found that they were not only very old, but we were looking into the first billion years of solar system history in what we were investigating. And that is the part of Earth history that is largely obscured to us. And so the moon is telling us, and has told us a great deal about the history, primarily the impact history of the inner solar system, and what was affecting the Earth during its one of its most critical periods, and that is the period when life was evolving on the planet.
You collect more than 100 kilos of rocks when you were in the moon. Which was the strategy to decide the sampling methodology?
Well, we carried with us to the moon the basic tactics and strategies that we use in Earth science here on Earth, and that is that you plan the best you can your investigation, your reconnaissance and your investigation of a new location on the Earth or on the moon, and then you put experienced and trained people there in order to use their intellect and their training and their experience to select the samples that will best represent what nature has produced at that particular site. And from those samples then, by later analysis, you expand the understanding of what you have found.
But you are never been there before.
Well, geologists have never been a lot of places before. When the first geologists began to explore the Earth, well, they had never been there in a geologic sense, had never been there before. And so the strategies remain the same. Techniques change, the analytical capabilities change, but the basic strategies are the same. You use your experience, your hands, your eyes, your brain, to decide what are the best samples, what are the best observations that you need to make, what are the best tools you need to apply to gather data. You gather that data and you gather the samples, and then you work on them in the laboratory to try to better understand the geologic history of the location, what made things the way they are.
How scary was the splashdown in the middle of the ocean with Apollo 17?
It was not scary at all. The whole mission had no fear or associated with it, primarily because of the training. Now, if you're going to be afraid to go into space, you probably won't ever volunteer. Those people that volunteered then were well trained. We'd gone through the mission profiles many, many times, and so you're familiar not only with what you have to do, but more importantly, you're familiar with the thousands of people who are supporting you and what they're going to do. That is probably the most critical thing. Everybody thinks the astronauts did the space program, but they didn't. The astronauts were just the tip of the spear. That spear was being held in the United States by 450,000 other Americans. And they were the ones that made it possible for us to be on the moon. It wasn't because of the astronauts. We just happened to be at the right place at the right time and very fortunate to be there.
So how many of these memories about these extraordinary experiences are memories or just memories of memories?
Well, I think all the astronauts are asked to discuss and to relate their experiences so often that they're true memories. And of course, the records are quite extensive, not as extensive as one might like, as I have found recently, but still the transcripts of the missions are there. You know what people said, you know how the equipment worked and what the checklists had in them. You can go back and see the records of your training and that kind of thing. So the memories are very real. There was a real experience.
Now, I know that all astronauts stepping on the moon, they have been members of the United States Armed Forces, not you. Did you have an intimate, different perspective from them about what you were doing?
I don't think there was a great deal of difference between in the perspectives between the civilian astronauts and those that had received their pilot training as members of the military. I received my pilot training from the Air Force, but I was a civilian at the time. And so there was a great deal of merging of experiences and disciplines between the pilots and the civilians. We have to remember that I was not the only civilian to walk on the moon. Neil Armstrong had been a civilian for 15 years, I believe. He was an employee of NASA, the X-15 rocket plane program.
But he also served.
But he had gotten his pilot training as a member of the Marine Corps. And the other astronauts that went to the moon had received pilot training as members of the Corps. But on the other hand, as part of their training to work on the moon, to explore the moon, they received a great deal of training in geological techniques. They couldn't receive the experience that a professional geologist would have. That just takes time. You can't shorten that. But we could give them the basic tools and approaches and strategies and tactics for dealing with a new exploration environment, and that's what we did. So they received a great deal of what you might call civilian training, even though they had received their pilot training and their previous experiences as members of the military or as members of NASA's Test Pilot Corps.
Jack, much of the moon missions at that time, they had political backgrounds. How much did you feel the political pressure during your mission?
I wouldn't call it political pressure. There was a great deal of patriotic pressure. I think everybody in the United States space program felt that it was extremely important for the United States to win the race to the moon. That was the primary purpose of the Apollo program. People should not forget that. It was a geopolitical competition with the then Soviet Union that was extremely important to the reaching a conclusion in the Cold War. We didn't know how important at the time. We just felt that it would be very important, and that Eisenhower, who basically started the Apollo program, and Kennedy, who articulated it and gave us the specific challenge, that they understood, and I think we understood also, that this was extremely important for for freedom-loving people throughout the world, and that it was not something we intended to fail at. Now, at the same time, some in the science community, Harold Urey, Eugene Shoemaker, Harry Hess, people of that kind, were pushing NASA to also implement a strong exploration program at the same time that we dealt with this geopolitical challenge that had been provided by the then Soviet Union.
So after all, was it like very important, the goal of reaching the moon for political issues?
I'm questioning the use of the word political.
Well, patriotic, sorry.
It was geopolitical in the context of the United States being the champion of freedom, and everybody involved in the Apollo program felt that it was very, very important for us to succeed in winning the race to the moon. Science came on as a backpack, if you will, of that effort. And we did very well with it, but that was not the primary purpose of the Apollo program. And the primary purpose was to protect freedom on this planet. And you can call that political if you want. I call it a natural inclination of the human species.
Yeah, you have been senator for one term in 1977. What is the difference between talking with researchers and talking with lawmakers?
Well, the primary thing is that engineers and scientists are always attempting to solve problems. There are exceptions, but they're attempting to solve problems and to find solutions to problems, whereas most lawmakers come out of the legal profession and they will tend to treat the symptoms of problems. They're not as interested in removing the causes of a problem rather than they're interested in treating its symptoms. And so that's a very fundamental difference, and it comes out of the education system of how scientists, engineers, and almost everybody else on the planet is educated. We're all educated, whether you're a housewife or a professional scientist or somewhere in the mix between, you have to solve life's problems. Well, lawyers don't have to do that, and it's just the nature of the profession. They are treating the symptoms of problems. A problem occurs and they treat its symptoms, but they don't worry very much about why did that problem occur. Scientists and engineers always worry about the why and try to solve it and get rid of it so you can move on to the next one.
One of your assignments during your term was on the Committee on Ethics. What did it consist of?
The Senate Ethics Committee was created and existed in order to provide a forum for complaints against senators who may or may not have committed some breach of what was considered ethics. And there was a set of rules that the Senate approved that somehow or another was supposed to define ethics. Now, I was there very reluctantly because I don't think you can define ethics. It's either something you have or you don't have. Yeah. And as soon as you make rules, people will start to try to go to the edge of those rules and maybe a little bit beyond. And the Ethics Committee ends up ruling on whether they have gone beyond the rule or not. And it just, I think it's an unworkable situation. But we were charged with investigating allegations and potential allegations against senators and senatorial staff that might have violated the ethics rules of the Senate. However impossible a task that might be, that was our charge.
Any difference in ethics between Republicans and Democrats?
I think that all human beings have a general understanding of what is ethical and what isn't. It may be that some push the rules a little bit harder than others, but I don't know that that's really related to party affiliation or not. There may be some differences in belief about what is ethical or not, but still, we had as many problems, I think, in the Senate Ethics Committee with Republicans as we did with Democrats. But at the time, there were more Democrats, so we probably had more problems with Democrats.
I know you were sitting, I read you were sitting in the so-called candy desk. Is that true? The candy desk?
Well, you know, I've heard that I've seen that written, but I really don't know. That did not register with me while I was there. That may be something that came along a little bit later, that somehow or another there was candy stored in the desk that I had. That was not something that I was aware of. I think it happened later.
So you have been a senator, a teaching fellow, a professor, a researcher at USGS, an astronaut, Is there a common thread?
Well, I think there's a common thread in that I was able to get a broad enough education that I could change careers whenever it seemed appropriate to serve. And that, I think, is the most important message that my career gives, is that we have to develop a far better education system so it's not luck, and it's not the luck of the draw of whether you've had an opportunity to get a very broad education. My parents began that education, and I was fortunate to believe that education was important, but I have to give them the credit for teaching me that. But then I had just many opportunities. I was able to get into Caltech, Fulbright to Norway, and Harvard. All of these were opportunities I had to take advantage of what my parents really had begun. But not everybody has that same environment. And so we have to have a public education system, at least in the United States, that offers a far better set of opportunities to young people than are being offered today. Frankly, as I've said in many things, I think today, in the year 2011, the government-run education system of the United States is broken, and that generations of young people have lost and are still losing the kind of opportunities that I had because of the dysfunctional nature of that system.
What happened exactly when you decide to change your career? What happened? Because you had the right tools because of your education, and you had the chance to change your career. What happened?
Well, first of all, you have to recognize opportunities ahead of you, and then you have to evaluate, do I have the educational background or the experience background in order to change to a career that where it seems like the opportunities to serve are greater, and the opportunities to learn are greater. That's just something that you have to evaluate with each new opportunity you see. Seek out those opportunities, but you have to evaluate and see if you want to make a change or not, and if you have the skills and the experience in order to make that change. I was fortunate that every time a new opportunity came along that looked like it was going to be important either to my career or to the country, I was able to make the change and apply my old skills and learn new skills to that kind of an opportunity.
Are you happy with all of your careers?
I don't have any regrets. I think things have gone reasonably well. You never know everything that's going to happen to you. That's what makes life exciting.
Here's another of your careers: freelance writer and speaker on matters related to space, science, technology, and public policy. Can you talk about that?
Well, it's just another one of the opportunities. Because of everything I've done, people seem to be interested in my thoughts and opinions on a wide variety of subjects. And in particular, right now, in how I think my life experience relates to the current problems and issues of today.
So, I counted 28 special honors. Is there a threshold after which the awards just rain down on you?
Well, most of those awards just recognize an event, namely going to the moon and returning safely to Earth. And they're not so much awards, as I indicated earlier, so awards for me, but for what hundreds of thousands of Americans did in a very, very fine part of our history, and that was the late 1960s and early 1970s when we went to the moon.
So people now expect NASA to go to Mars. But which is the main reason to be of NASA today?
I'm not sure who expects NASA to go to Mars, because there is no clear-cut space policy today that would get us there. Now, there are many people who want to go to Mars and would like to see the United States lead that effort, but I'm not sure that the current policy of the United States of America is really going to get us there.
So which is the main reason to be of NASA?
Well, that's a good question. You probably have to ask NASA that.
And you conducted energy research and development for NASA, and you have ideas about the future of energy resources, like you proposed the use of the lunar helium-3 as a fuel for national nuclear fusion reactors. How would it work?
Well, helium-3 is nearly ideal for fusion energy production. It's undeveloped at the point, but we know enough, and we've had enough experimental work, and that the concept is proved. It's proven, and that means that I think we should move more aggressively towards understanding helium-3 fusion. The reason it's an ideal fuel is that it produces no residual radioactivity in the fusion process, unlike deuterium-tritium fusion, which is the main global research effort at the present time. Unfortunately, helium-3 is present in abundance only on the moon. That's accessible to us. There's helium-3 elsewhere in the solar system, but the moon is only 3 days away, and so you have to consider it part of our accessible environment. And it's going to take a major, I think, private sector effort to develop the launch vehicles and the infrastructure necessary to produce helium-3 on the moon and return it to Earth for use in fusion reactors that are yet to be developed as well.
There are some studies that say that this is widely impractical. How do you reply to that?
Well, I haven't seen those studies. There are people who express that opinion.
I
have done studies, and my colleagues at the University of Wisconsin have done studies that say it is within a certain economic envelope, financial envelope, it is practical. It could be done.
This is Todd Harrison, MIT, 1994. And in 2008, you said that global warming scare is being used as a political tool to increase the government control over American lives, incomes, and decision making. Do you still think that?
I think that is exactly the purpose of those people who are trying to control government policy based on what I think is faulty science. Science that alleges, as one hypothesis, you have to think of it as a hypothesis, that human beings' use of fossil fuels is creating a global warming crisis. And I see no natural evidence that that is true.
So which is the weakest technical point of the global warming or climate change theory?
Probably the weakest is that when you do an isotopic mass balance of the carbon dioxide in the atmosphere, it turns out only about 4% of the carbon dioxide we're breathing right now comes from fossil fuels. The rise in carbon dioxide over the last 50 years or so that we've been measuring, and it's probably been occurring longer than that, is a result, almost certainly the result, of a gradual warming of the Earth's climate coming out of the little ice age that devastated Europe in between 1400 and 1900. Really, the little ice age lasted that long, but we've been in a warming trend since about 1660. And as the Earth warms, it's going to create more carbon dioxide. Part of it is released largely from the Southern Ocean, from the deep waters of the ocean, and part of it through enhanced biological activity and biological decomposition. So there are many ways in which carbon dioxide can be rising at the present time, and that we know that there's very gradual warming, about 1 degree Fahrenheit every 100 years, or 0.5 degree centigrade every 100 years, and that's just a fact. And that's happened before in Earth history. There's geologists know what nature has done with respect to climate, and that's, I think, probably why I question the hypothesis that human beings are causing the current warming. There's just too many other. There's another explanation, a very clear explanation, that it's a natural phenomenon.
You say that the environmental movement is related to communism in an interview in 2009. There's a good amount of researchers representing International Academy that continuously publishing peer reviewed journals about the global warming. How could science be so profoundly affected by politics?
Well, first of all, I never said that the environmental movement was made up of communists. I said communists found the environmental movement and have entered it. And the environmental movement does try to get increased government control over the lives of ordinary people. So that is a fact. Now, how do scientists get wrapped up in this? Well, there are, I think, a number of ways in which it happens. Unfortunately, government funding of science biases science. If you want to work in the field of climate research today, a large part of the funding comes from government, and government has a position on climate change. The government of the United States, at least, believes that, or has as policy, that humans are causing the current warming. And so unless you put into your grant proposal or into the reports that come out of your grant work that humans are causing global warming, the chances are you won't get funded the next time around. So there's a very strong bias. That's why I think it is very unfortunate that the United States government funds so much of scientific research today.
Is that true for the last 10 years or just for the few years?
It's actually started with World War II, and a necessary event in World War II was the government had to fund a great deal of research related to the war effort. It also was accelerated by the NASA program, by the Apollo program, when so much government money began to go into space research. And part of that space research has morphed into climate research. And so most of climate research today is funded by the government. And so the biases of government and your funding agencies are going to be reflected in what scientists say. And the National Academy of Sciences, which is one of the big advocates of the hypothesis of human-caused global warming, gets the vast majority of its funding from the United States government.
And that's true for even if the government is Republican or Democrat?
It's been true, yes. It's been true for many decades, really since World War II.
So how could it be that the scientists, they can't convince the government that that's not true?
Well, the scientists are dependent on, if they want to do science, they're dependent on funding. And those people, most of the people who have alternative hypotheses of the cause of the current warming trend are independent. They are not being funded by government. It's a very, very clear
Who are they funded by?
They have either private funds or their own funds, or they bootleg it in some way, or like myself, I'm still working as a consultant and everything like that, but I put a lot of my time when I'm not earning a living working on this subject, and people do that. There are a large number of people, thousands, tens of thousands throughout the world who are working on this and are finding that the hypothesis that human beings are causing global warming just doesn't hold up.
So in general, we have a problem of the independence of the researchers.
Exactly. Research has to be independent of the funding sources.
And how do you do it?
Well, you have your own integrity to make sure that's true. We're right back to ethics again, and scientific and professional ethics should determine that you never give the funding agency the answer they want to have unless it is scientifically valid.
Jack, what do you think about the youngest generation?
Well, I think every young generation has all the potential that you can imagine. And if we take advantage of that potential with a decent education system, well, then I have great confidence that the young generation in the world today will be able to solve their problems in the future. But right now, we're making it very difficult for that to happen.
This is in the United States?
Everywhere.
Everywhere. Okay, well, thank you very much, Jack.
Thank you.
This was Jack Schmitt, the geologist astronaut that put his foot on the moon. Thank you very much to Jack Schmitt. Thank you for listening. This is Mini Geology radio show. I am Daniel Minizini, your inquisitive geologist. You can listen to this again on the website minigeology.com. You can write me at minigeology@gmail.com, suggesting who to interview, proposing concepts and ideas to develop together. Thank you very much. Have a nice day.
And touch my limbs. It wasn't difficult to pull me from myself again. And in our travels, we found the roads. You held it like a mirror, showing me the life I chose. And I returned to my beautiful city. Black skies changed into blue. And my love is so wise and so pretty. But some nights I still dream of you. Dear fellow traveler under the moon, I think I'm growing weary and I'm hoping you'll come soon. And if I see you in clean new clothes, I hope you hold the mirror up to show me what I chose. And I'll return to my beautiful city. Black skies will change into blue. And oh, my love is so wise and so pretty. Some nights I'll still dream of you. And I'll return to my
Absolute pleasure.
Bye.